Alright, welcome back to Videoland, boys and girls. Alright, now we're going to be talking about properties of logs. We're going to evaluate, expand, and condense logs. Okay, to evaluate them, one thing you might need to do, depending on the messiness of the numbers, is use the change of base formula. Okay, now the change of base formula actually is a little bit outdated because of the TI Nspire. This was necessary, at least until the Nspire, because calculators only understood log base 10 and log base e, natural log. Okay, so if you had some combination of numbers here that didn't work out nicely, you could type them in your calculator using this formula here. Notice that the A and then the subscript B, the A is kind of the higher number and it goes on top, and the subscript is lower and it goes on the bottom. So that's basically how I remember where to put the numbers and everything. But this is a way to have non-Nspire calculators work this out. If you have the Nspire, you can actually type in any base you want, so this isn't really a very necessary formula for it. But here we go. If I've got log base 4 64, well, I'm doing this one just to kind of work with something that I know is going to work out, because 4 to the third is 64. So I know this thing is going to equal 3. But just to demonstrate this thing in action, change of base formula that is, okay, I can either pick natural logs or common logs, whichever. So for this one I'll just pick common logs, just because I feel like it. Okay, so I'm going to have to do log of 64 over log of 4. Alright, and if I crunch the numbers individually, log of 64 is some big nasty decimal, as is log of 4. However, if I take those two decimals and divide them, I very, very magically, seemingly, get a very, very nice answer of 3, which again is what's expected out of here. So, I challenge you to type that in a couple different ways, make sure it works. Okay, but what that's good for, again for non-Nspire folks, is if you've got this sort of thing, log base 7 and 19.2. Okay, I'm going to look for an answer to 3 decimal places. Although one thing you can do, and I know this is a horrific idea for you, some of you guys, but you can estimate this. Like if I'm doing 7 to some power to get 19.2, because again that's what log means, well if it's 7 to the first that'd be 7. If I did 7 to the second that'd be 49, and because 19 obviously is between 7 and 49, my number should be between 1 and 2, the exponents that take you there. Okay, so I'm really expecting my calculator to spit out 1 point something or other. Alright, so basically as I start typing this thing in, I'm going to do log 19.2. I could have done natural log if I felt like it. And then I have log 7. Okay, and hitting the magic buttons on my calculator, I get something 1.5, 185, etc. 5.2 actually, a little bit messier decimals, but I'm going to round to 3 decimal places. So basically that's going to equal to 1.51, and then I ask myself, do I keep the 8 or make it a 9? And in this case I certainly make it a 9. Okay, there it is again, Nspire, so you can just type that in normally. People without Nspire, that's what you're going to have to do. Okay, now hopefully that change of base formula we just did was something that sounded familiar from Algebra 2, because it was, as are these properties right here. Okay, now we've got 3 different properties for logarithms. We've got product, quotient, and power, and basically here's what it is. If I have the log of any base, and I have some kind of a product going on inside the log, well sometimes it's convenient to break that up. And the property goes like this: log base b of x plus log, okay, make sure you maintain that base, so base b of y. Okay, now remember, a log is an exponent, and remember when you're multiplying two things that have exponents on it, what you really do is add those two exponents together. So basically that's that same property just kind of translated into logs. Same thing with the quotient property. Okay, if I'm dividing two things with exponents on them and I have the same base, well, we subtract those exponents, so basically that's what we do with the logs if we'd like to break this guy up. So this will be log base again, whatever that is, and you always do top minus bottom, so same thing's true here. So it's going to be log of x minus log base b of y. Again, hopefully that sounds familiar. Okay, same thing here. Okay, when you have a power to a power, again here we basically have log and got the number going to a power, and well, anytime you have a power to a power, you multiply the exponents together. So this one's a little bit different, but basically I'm going to turn this mess into a multiplication, and I'm going to do that by pulling this n kind of out in front as a coefficient. So we have n times log base b of x. Again, where that n is, well, it could be a variable, it could be a number, it could be whatever, but it kind of becomes a coefficient of sorts to the log. And those are the 3 properties, and we're going to start using them to do some other things in just a second. One of those things we can do is to evaluate logs without a calculator. Now granted, this first one, hopefully you can just look at that one and go, oh wait, that's -2. because to get from 9 to 81 it needs to be squared, but we need to flip it, and of course that's a negative exponent. Okay, but just to demonstrate those properties, okay, I've got log and now I've got a quotient actually. So now what I can do is break that into a subtraction. So log base 9 of the top, in this case 1, minus log base 9 of the bottom, 81. Okay, well, log base 9 of 1, well, 9 to what power is a 1? It's a big fat 0. Okay, and now minus log base 9 of 81, well, 9 to what power is 81? That's a 2. And let me check my calculator here real quick. 0 minus 2. Oh, yeah, turns out to be negative 2. Okay, which again is what we initially thought. Okay, if you have something a little more complicated as this, well, here's our properties in action again. Okay, we can take this guy, and again, if that's not something you can kind of quite do in your head real quick, then here it is. Alright, so I've got log base 4 of the cube root of 16. Well, holy cow. Let's go log base 4. Well, if you remember, the cube root is the same thing as the 1/3 power. Okay, and that's kind of convenient for what we're doing right here, because this becomes now log base 4 of 16 to the 1/3 power. Now that 1/3 power we can yank out in front as a coefficient, so now I have 1/3 log base 4 of 16, and well, log base 4 of 16, okay, from what we've done previously, that should get you to a 2 very, very quickly. And then of course you have to call up your 5th grade teacher and ask them how to multiply 1/3 times 2, and 1/3 times 2 is actually 2/3. Okay, hopefully you didn't have to call your 3rd grade teacher. Alright, but there you go. So that's how those powers could help us evaluate some of these things without a calculator. After those last ones, I'm sure you're thinking, yeah, Mr. Osborne, make it harder. This is too easy for me. So, okay, here it is. Alright, so if I've got some kind of expression like here, natural log e to the 5th minus 4 natural log squared to e, okay, well, again, we can kind of tear these things apart a little bit using those properties to make them a little easier to work with. Okay, and again, there is that inverse property that we have here that hopefully would quickly get you actually to a 5, but just to show these other properties in action. Okay, the 5 can come out in front, so this thing becomes 5 times the natural log of e, and then I've got the, well, let's go this, minus 4 natural log, okay, and again, the square root of e is the same thing as saying e to the 1/2 power. Yep. So I'm going to take an extra step here, please bear with me. 5 times natural log of e minus, well, if the 1/2 comes out in front and hits that 4, well, we're going to multiply, and of course 4 times 1/2 is actually just a plain old 2. So then we got natural log of e again. Alright, so, well, 5 times the natural log of e, well, what power of e makes e? Well, of course, that's the first. So that's really 5 times 1, minus, same thing here, 2 times 1, and pardon me for doing all this in one step, but of course 5 times 1 minus 2 times 1 is 3. Alright, so, hey, let's try this thing, because that looks just crazy over there. Okay, because I've got log base 2 of 192, and, well, hey, that doesn't go evenly. 192 is not a power of 2, or at least a nice one. Okay, but, again, using our properties, well, hey, it's a subtraction. Okay, now I didn't do it in this last one because it was convenient basically not to, but this one, because I have no nice way of breaking up anything that I have, I'm going to use that quotient property here kind of in reverse and turn this into log base 2 of 192 over 6. Okay, well, log base 2, well, 192 over 6 works out to be, and if you need to type in your calculator, but hopefully you can kind of mess with that, and, God forbid you actually do this long division right here. Let's see, 3 times that's 18, subtract, you get a 1, 12, okay, 32. Alright, so that's log base 2 of 32, and hopefully, whether you don't have that memorized or not, okay, you can eventually figure out that log base 2 of 32 is actually 5. So, again, without a calculator, there's a couple ways to turn some nasty looking log things into some fairly nice numbers using those properties. Alright, another one of the things that those properties can do is allow us to expand logs. Now, our goal we're shooting for here, as it says, is to get multiple logs of a single letter or variable. Okay, because basically, right now I have one log of this big mess right here. And sometimes, if I can kind of tear it apart a little bit, some of those individual pieces I can work out a little more nicely, and it's just easier to kind of deal with sometimes. So, that's what we want to do here. Okay, log base 3 of 8x to the 5th. Alright, so, well, first thing first is I've got myself a situation here where I've got an exponent and I've got kind of a multiplication going on. So what you need to ask yourself is, hey, is this overall, if I had to call this thing something, would I categorize this as a product or as an exponent? Because then that's going to dictate which property I use. Okay, well, notice how the 5 doesn't have anything to do with this 8. So overall, I've got to call this thing right here a product. And since it's a product, that's the rule I have to use first. Okay, so what that does is allows me to turn this into log base 3 of 8, and again it's a product, so that becomes a plus. Log base 3 of x to the 5th. Okay, and now individually I could look at these two things and make some more decisions. Okay, first of all, log base 3 of 8. Well, there's not a lot I can do with it. You might look at that 8 and think, hey, I could turn that into 2 to the 3rd, and then I can bring a 3 out in front. So if you want to do that, I wouldn't fault you for it, but because it doesn't do us much good, I'm actually going to leave that alone. And just leave this guy as log base 3 of 8, and he's going to stay that way. However, this other guy, I've got this exponent here, and that exponent can come out in front. So plus 5 log base 3 of x. Okay, now notice I want multiple logs. I've got that. I want a single letter or a single variable, and that's what I have here. I got a single number, got a single variable, and basically I can't do anything else. Because again, 3 doesn't become a nice power to get to 8, so I'm not going to try. We could use that change of base formula, but that's going to give us an icky decimal, and I don't want to deal with that right now. And same thing here. It's just got an x. Obviously, 3 to what power is x? Well, if I knew what x was, I might be able to do that, but since I don't, I can't. So basically, this is as expanded as it's going to get. I got another one I'm still trying to expand. Now this one I've got log of this big fraction-y sort of thing, and I've got an exponent on there. And again, I have to make a decision. Am I going to call this thing more of a quotient or more of an exponent? Well, again, that 3 applies to the quantity on top, but it has nothing to do with the number on the bottom. So again, this is more of a quotient than it is an exponent. So the quotient rule is what I'm going to use first. So I'm going to have log of the top, x plus 9 to the 3rd. That's pretty bad 9, sorry about that. Okay, now it's going to be subtraction, log of 10,000. Alrighty then. So now taking a look at this, now I have this sum, and I don't have a sum rule at all, but actually that's irrelevant right now because I do have this 3 as an exponent, which is an exponent for every bit of the thing inside the log right now, so it's definitely something I could yank in front as a coefficient. So now I have 3 log x plus 9. Okay, and now I have minus, okay, log of 10,000. Well, wait a minute. Log has a little subscript of 10 there that I don't bother to write in. And let's see, 10 to what power is 10,000? That is something that works out nicely, so that is something I want to do. And of course, I've got 4 zeros on the 10, or 4 zeros after the 1 rather. And so basically what that means is 10 to the 4th is 10,000, so that expression really just turns into a nice pretty 4. Okay, now again, some people are going to be tempted to try to distribute the log or something like that. Please don't do that. A log is a function and not a term that can be distributed. So basically, moral of the story is, this guy right now is as expanded as it can get. Because again, the single term is not exactly what we have, but we are stuck in a position right here where I just can't go any further. I don't have any rules allowing me to do anything there. So I am stuck like Chuck. There we go. Okay, well, when there's expanding, there's condensing. And condensing logs is basically doing what we just did in reverse. Okay, now our goal, okay, like our last problems, we started out with log, a single log of a big mess, and we broke it into little pieces. Now we're going to start with those little pieces and try to go back to the single log of a big giant mess of whatever it is. Alright, and we don't want to have a coefficient on there, just one little thing to keep in mind as you do this. If you're with a coefficient, then you're not done. Okay, well, again, looking at all these guys, I've got this mess here, and I've got several coefficients. Well, as soon as I have a coefficient, that means I can turn it into an exponent. Okay, so basically all of these guys are going to jump up on top of the variables inside the log that I have. Okay, now be careful. The 3 jumps up, that's easy. This 1/4, as he jumps up on top of the y, there's something kind of special there. Okay, and then I've got this 5 jumping up on the z. Okay, you could take a -5 onto the z if you wanted to. I prefer not to. And just leave it as a subtraction, so I'll use it as a quotient later. If you incorporate the -5 jumping up on the z, you kind of have to put a plus sign in the middle here, and then you'll have z to the -5th, so it flips upside down anyway, and kind of accomplishes that whole quotient thing. So since it'll happen one way or another, I prefer not to deal with a negative exponent if I can help it. Okay, that being said, as this goes into play here, I get natural log of x to the 3rd. Okay, plus. Okay, and now remember, the 1/4 power is kind of awkward to write. What's just more convenient usually is a root, and the 1/4 power becomes the 4th root of y. And then again, like I said, I'm going to leave that as a minus, and the 5 jumps up and becomes natural log of z to the 5th. Okay, Okay, and depending how good you get at this, you actually probably could do this whole problem in one step, but just for the sake of showing what's going on, I'm going to do it in several. Alright, now first thing first, I've got this addition. Okay, basically working from left to right because I don't have any sort of parentheses or brackets or anything forcing me to do one thing before something else. Okay, since that's the case, I have an addition, so I can turn that into a multiplication. So natural log of x to the third, and then just be careful how you write this, so your 4 is definitely the index and the 3 is definitely an exponent out there. Okay, so natural log of x to the third, 4 through to y. Okay, and I'm still going to have this minus natural log of z to the fifth out here. Okay, but now I have log minus log, and anytime I have log minus log, well, I can turn that into a single log of a quotient. So now this becomes natural log. My numerator becomes the x to the third, fourth root of y, and then my denominator becomes the z to the fifth. Okay, I'm begging you, please don't write it as a natural log on top and then natural log on the bottom, because that's basically what the change of base formula is, and that's not what we're doing here. So please avoid that sort of mistake. It makes me sad. But anyway, here's our final answer. Okay. And so this slide's going to do some double duty for us. We've got a word problem and then the homework. Okay, instead of just saying 1 through whatever enough, I just picked the ones that I kind of like the best out of the deal. Hopefully those help you get a good look at what's going on. But anyway, okay, for the word problems, we've got our decibel formula again. So there it is. Alright, so a noise intensity of whatever is how many decibels. Well, of course, this one's pretty cut and dry, so I probably don't even need to bother doing this with you guys. But anyway, decibels is 10. Intensity is what goes inside the log in the numerator. So 4.75 times 10 to the negative 9th, and that's all over 10 to the negative 12th. Okay, throw that whole thing in parentheses. And once we get it all in parentheses, we type in our calculator. And this is one of those things that actually seems pretty innocuous, but it's one of those things that people tend to mess up on the calculator. So please, as you do this, please do test this out and make sure you can get your calculator to spit out 36.7669 and a whole bunch of other decimals. Alright, with this I'll probably on a quiz ask you to round to the nearest tenth. So this works out to be approximately 36.8 decibels. Alright, so there it is. There's the homework, and I'll see you guys in class.